Okay, so let's get started. We're going to be taking a look at working with our normalized knock correction mode within our Link G5 and G4X programming. Now, our normalized knock mode is something that's came about in the last few years within the Link G4X and now the G5 system. So it's something that they've introduced, and it's essentially an adaptive type of knock control. It actually takes a lot of the setup and work out of the old traditional standard style knock control that we've talked about already, specifically the knock threshold table and a lot of the other details for programming. So it simplifies setting up the knock control, and it actually works fairly well for most engines I've tested it on. What we're going to do is go through some of the settings and configurations and actually configuring it in a file here. Then we're going to take a look at two example calibration files and two data log files so we can get a little bit better sense of how this all works and fits together. Now, what I'm going to do is provide an actual tuning demonstration live with a Honda K-Series engine and going through dialing in the spark timing as well as working with the normalized knock mode so you can see the process and the order of operations. It'll probably be a little bit more clear at that point how this all works, but I wanted to actually set a video here, set up a video for taking a look at configuring all this and going through all the various settings, because again, there's a lot of details that we have to make sure we understand. It is a little bit more complex in some ways than the standard knock control. In other ways, it makes things much easier and much simpler to set up and to work with. All right, so what we're gonna do is move from our basics page right here, and we're gonna go across. Now we know we have our knock page right here, and we can work in this specific knock page layout, but what I'm going to do is actually go into a new page called Normalized Knock. This is gonna be specific for working with our normalized mode. This page will work for the standard mode. If we're doing normalized, we're gonna go to a different page. So let's go across here, and it's gonna be towards the end of all the pages available in our layout. So we're going to go to our knock normalized. Now in here, we need to go and set up a few things. Some of this will look familiar and feel familiar if you're used to dealing with the standard knock control tuning and working with the knock control and the link. Some of this is going to be new. So let's try to break this down and understand what's going on here. So under our knock setup, we have our knock mode. We know we need to turn this on. If we go here, we're going to have some options: ignition trim, fuel trim, ignition and fuel trim. This is the standard older style knock control. Then we have the option here for normalized options. And as I mentioned in our previous knock tutorials talking about the knock control, I always use just ignition correction only for knock control. I don't find it very useful to have fuel or fuel and ignition. It doesn't seem that the fuel does a whole lot for suppressing knock. The ignition is an almost immediate correction to knock, and it's my opinion the better way to go for working in knock control. So I'm gonna go ahead and grab my option here, normalized ignition. Let's click OK here, and we can see it's gonna start to populate a lot of windows and a lot of settings. Now it looks really, really overwhelming with all these tables here. We're gonna talk about what these do and how they actually work. And when we look at the data log, it'll make a lot more sense fitting these tables to looking at actual data as we're trying to calibrate the system here for knock control. What we want to do here just real quick is open up our knock threshold table. So we're going to double click that little square icon so it brings our table up onto our screen here. So again, the knock threshold table is going to look familiar to you, but how we're going to implement it is completely different for this normalized knock mode. Now, let's go through some of our other settings here that we have to work with. So some of this will look familiar if you're used to the standard style knock control. So we have our disable input. We don't want this disabling anytime, so we're gonna leave it off. Then we have our frequency channel. This is something that's important based around the knock sensor that we're working with. This is saying if we have our wideband options here, so we have two options. We have 4 to 10K kilohertz wideband. We have 10 to 16 kilohertz wideband option. This is used if you're looking at the first order frequency or the second order frequency for a Bosch flat response style knock sensor. So this is saying that we can look over a broad band of frequencies where those flat response sensors are much more reliable in compared to a resonant sensor. Resonant style sensors, an OEM sensor, you'll find a lot of the older 90s, early 2000s era Japanese and OEM, even domestic engines. You'll find that those are a single wire. That's how you distinguish between typically flat response or resonant, although resonant can have 2 wire, but typically they're 1 wire. So we choose one of these two options, first or second order frequency, for a flat response. Now we can use, if we go back in here to our Excel spreadsheet calculator from our training course, we have the ability to enter in the bore size, either in millimeter or inches, and calculate the first or the second order frequency. And that's what we want to keep in mind as we're looking at that frequency setting. So if I'm using a flat response sensor, and let's just say I have an 86 mil bore, that's pretty standard for a normal 4-cylinder engine. 86 mil bore is going to tell me I'm either at a 6.66 first order frequency or a 13.32 second order frequency. So in that case, I know if I'm running a Bosch flat response sensor and the sensor is relatively quiet, I don't really have any issues with the amplitude output, the noise to signal ratio from the sensor, I can use the first order, and that's going to tell me I fall within the 4 to 10 kHz frequency range that we want to sample in the setting for the software. If we're finding that that Bosch flat response knock sensor is really noisy, then we can choose that second order. Again, that would fall in that higher frequency range here when we select things. If we go back in, the 10 to 16 kHz. So it's really going to be first or second order for a Bosch flat response sensor. Almost always, every single engine you'll ever probably calibrate and tune will be fine with a Bosch flat response on the first order frequency range here. Now, if you do have a resonant style sensor, you can go in here and select a narrow band, so it's very narrow where it's looking at the acceptable frequency, the ringing frequency, and based around the bore size of the engine. That's how knock sensors are going to be functional. We want the knock sensor to be around that correct frequency range. What'll happen is if you have the incorrect range selected on a resonant style sensor, you'll find the sensor is either really, really loud or really, really quiet. Essentially, we're not getting into the usable range for the sensor. So when we have a resonant single wire sensor, we typically want to look at the second order frequency, although you can start off with a first order and experiment. Again, if you have that resonant sensor, you can go into your Excel spreadsheet here, punch in your bore size, and then see what it gives you for the first or the second order. Now, if you're finding in this situation, let's say 86 mil bore, we can see here 6.66 in the first order frequency and 13.3 on the second order frequency. If I want to go in here and enter a narrow band type of option for a resonant OEM style sensor, I would need to go into the software here and take a look at my choices. Notice that they're only moving in here in essentially 1 kilohertz increases and that narrow band as it's looking at the sensor. So if I have a sensor that's 6.66, I'll round it up and go to 7 kilohertz. That's going to get me pretty close. So all right, let's go ahead and just assume I'm running a Bosch flat response because that's typically what I try to run. And let's go ahead and click OK, and we can see that's populated right there. The clear trim tables, we've talked about this. The trim tables are going to be storing any knock that is recorded during the operation at a particular load and RPM point. I actually don't have the trim tables populated in this window. What it's going to say in this case of using the ECU powered on option is that if we turn the key off and then turn the key back on again, repower the link, it'll erase anything it stores into those particular tables. So it's not storing that kind of as a long-term learned knock. It'll clear it out of the memory and it'll start over again. So that's usually what we want to choose for this option here. Let's go ahead and cancel. We have a window start, and then we have a window length. The window start is going to be how many degrees.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.